Question 6 relates to a practical investigation in which a series of haloalkanes have had their vapor pressure measured at 20 degrees Celsius. Now 6.1 asks you to explain what's meant by the term vapor pressure. This diagram on the right indicates a container shown in blue with a lid on and a liquid stored within that container indicated with the green markings. Now any liquid on the surface, some of the particles will have sufficient energy to break the bonds, and so you might have a few particles that evaporate, and those particles will be in the gaseous state, obviously within the closed container. And as those particles bounce against the walls of the container, they exert a certain pressure, and that's what is referred to as vapor pressure. So in terms of answering the question then, what's meant by vapor pressure? Vapor pressure refers to the pressure that's exerted by an evaporated liquid within a closed container. So it's the pressure exerted by an evaporated liquid in a closed container. Question 6.2 asks us to formulate an investigative question for this investigation. The key here is that it's a question, and the way you answer these types of questions is to firstly determine what your independent variable is, then determine what your dependent variable is, and then simply put those two together in a question. So our independent variable, that's the thing that we control, and this over here is our independent variable. You'll see that we have haloalkanes, chloromethane, chloroethane, and chloropropane. And you can see from methane to ethane to propane, the length of the carbon chain is increasing. So our independent variable is the length of the carbon chain. And for each length of the carbon chain, for each different length carbon chain, then we are measuring the vapor pressure. So the dependent variable is then the vapor pressure. So to put those together in an investigative question, you simply phrase it as, how does the independent variable affect the dependent variable? And so in this case we would answer this by saying something like, how does the length of the carbon chain affect the vapor pressure? How does the length of the carbon chain affect the vapor pressure? And as it's a question, we'll have a nice big question mark at the end. 6.3 asks us to give two safety measures for dealing with compound A, which is highly flammable. So the focus of our two safety measures that we give needs to relate specifically to the flammability of the substance. You need to be careful when answering these questions related to safety measures to make sure that you're being specific enough. So it's not good enough to talk about safety equipment. You need to be specific, and in this case goggles would be a good idea to protect your eyes against flammable liquids. And secondly, with flammable liquids, obviously the danger is of ignition, and so another sensible safety measure would be to ensure that there are no naked flames or heat sources or something like that in the vicinity. So those would be two safety measures to use when dealing with highly flammable liquids. 6.4 asks us to state and explain the trend that's illustrated in the table, and asks us to refer to intermolecular forces. Now you need to be careful in a question like this. Notice they're asking you to state the trend and then to explain it, and in your explanation you must refer to intermolecular forces. So firstly, to state the trend, you can see that as the carbon chain increases from methane down to propane, the vapor pressure clearly decreases. So from 506 down to 133 down to 0.13. So that's the first thing to do, is to state that as the length of the carbon chain increases, then the vapor pressure decreases. Put that in a nice clear sentence. Then in terms of explaining the trend, you need to make the point that as the carbon chain increases in length, the effective surface area increases, and hence the intermolecular forces, and this is the point at which we would specify those intermolecular forces. In this case, they are van der Waals forces, so the strength of the van der Waals forces increase. And then finally, your third point is because the van der Waals forces, the strength increases, there would be fewer molecules that would evaporate, or break free from the liquid. So let's just recap. The trend we see is that as the carbon chain increases, the vapor pressure decreases. The explanation is that as the chain increases, the effective surface area increases of the molecule, and hence the strength of the van der Waals forces increase. And finally, stronger van der Waals forces mean that fewer molecules will evaporate, and hence there will be a lower vapor pressure. 6.5 then asks you to compare 1-propanol compared to 1-chloropropane. And the key here is to recognize that the length of the carbon chain is the same. We've got prop there and prop there, and so each one has 3 carbons. And the difference, of course, is that our propanol will have an OH group, which means that the intermolecular forces will be different. And in the alcohols, the OH group means that there will be hydrogen bonds. So let's go ahead and answer the question. Would we expect it to have a vapor pressure that's higher, lower, or the same? Because of the stronger bonds, fewer particles will evaporate, and so we would expect a lower vapor pressure. So that's the answer to the first part. And then secondly, to explain your answer, and there we would need to say that the alcohol has got hydrogen bonds, which are stronger bonds than the van der Waals forces in chloropropane, and that means that fewer molecules will break free from the liquid, and hence the vapor pressure would be less.